Couple exponential equations here. This one's pretty straightforward. We're depreciating by 7% per year. The expression 11,330, that's your initial value. We have a multiplier that shows the 7% decrease, and people do all kinds of stuff. They'll put a 0.7 in because they see the number 7. They'll put a 0.07, the really clever ones, because they say, oh yeah, it's 7%. Well, that is 7%, but that represents a drop in 93%. This is 7% down from 100% of what we started with. So think of it in terms of a score on a test. If you lose 7%, depreciate. If you lose 7%, you got a 93% on the test. Congratulations, by the way. But that means we need to show this as 0.93, a depreciation of 7% less than 100%. And we're doing this for 9 years. That means we're raising it to the 9th power. And you can put all that stuff in the calculator all at once. 11,330 times 0.93 raised to the 9th power. And that gives you a grand total of depreciation 5896.26 if we're talking dollars, and we are. Right. Over here we're investing $2,450 into an account with 24% annual interest. Lovely. Tell me where that is. But we're compounded quarterly, which means we're getting paid interest every 4 months or so. Well, that means we aren't really getting paid 24% each time. We're getting 24% divided by 4, but we're getting it every quarter. So that means we're actually getting 6% per quarter. And we're doing that for 3 years. So my initial investment is $2,450. Contrary to what we did over here, where we took 4% or 7% away from 100%, we're actually adding the 6% to the 100%. So that's a growth of 1.06, 6% over what we started with. But remember, that is quarterly interest, and we're doing quarterly interest for 3 years. That's 4 times a year we're getting paid for 3 years. So there's a total of 12 payments. We plug all that in, we get the 2450 times 1.06 raised to the 12th power. That's 49.88 cents. Don't lose those.